Hello everyone, this is Kurotenchi here, and today I'm gonna explain this video the Null-varset glitch. This is a glitch of the Mugen engine that wasn't very exploited overall, but helped building new mechanics when covered on common fighting game mechanics to the Mugen engine, and also is a gain of readability whenever you are making a character yourself, and for some of the stuff, a gain of memory space. So to explain this glitch, I need to explain first how does a state controller work. Now I know what you're saying, it sounds basic. You make a block, you tell what kind of actions to do, under which conditions, following a series of Boolean tests, and you add in additional parameters maybe such as ignore hit pause, persistent, etc. But the way the engine reads your lines of code has more depth than meets the eye, and this depth comes with the acknowledgement of a little thing that neither the Mugen documentation nor Kung Fu Man came to explain, and that is double point equal. Double point equal is a binary operator commonly used in coding languages such as C++ or Python, and is used to affect the value to a variable. In Mugen, it works the same way, and so var47 double point equal 5 is the equivalent of a varset state controller assigning the value 5 to var47. Although it comes with a few limitations that I'll explain later. Now, the way Mugen reads state controllers is as follows. You have a list of triggers followed with numbers. As you would expect, Mugen starts reading trigger 1 lines first, then trigger 2 lines, etc. In Mugen, the order of lines, blocks, does matter. So Mugen starts with the topmost trigger 1 line, then evaluates the line to determine the Boolean value 1 or 0. Until then, nothing counterintuitive. But the reading of the next lines in Mugen depends on the value of the previous line. If it's 1, Mugen continues evaluating the next lines. If it's 0, Mugen skips to the trigger line of the next index, from trigger 1 to trigger 2. This little detail means a lot with the inclusion of double point equal, because when Mugen reads those lines one by one, it also computes this operator and affects the new value to the variable in the meanwhile. Thus, if you put 2 lines for trigger 1 with the first line being a condition like state null equal 1200 and the second line being the variable affectation, if the condition is verified, thus returns 1, the variable is modified. If not, the variable is left unchanged. But if you put both of them in the same line, the variable is reaffected anyway. Onward to state controller computation. If one trigger index sees all its line returning the value 1, it stops checking for other trigger indexes and start doing the action indicated in the type of the state controller. Then again, it brings more applications for double point equal. Assume that you have a first set of trigger 1 lines, like in the previous example, and then a second set of lines where the condition is more precise than the first one. Say we want another variable like var0 equal 1. Then say trigger 1 conditions returns var47 becomes 2, and trigger 2 conditions return var47 becomes 3. Then, since you're in state 1200, trigger 1 is verified, and var47 becomes 2. But even if your var0 is indeed 1, Mugen won't compute the trigger 2 lines, and even if all your conditions are met, var47 won't become 3. This shows how important it is to reorder your trigger indexes from most precise to the most global, so that all cases are checked and processed consequently. Last but not least, Mugen also evaluates double point equal with a bunch of rules. First, an affectation to root var something, or help per id var something, or enemy var something, or parent var something is considered as a syntax error. These are the first limitations of this glitch. You can't do absolutely everything with that. Second, something more specific with a state controller different from null. If you affect 0 to a variable using double point equal, it will return 0 as a Boolean value. So two things. The The line including the affectation will be the last line read by the engine, and the engine will start computing the next trigger index. So in the previous example, if you affect 0 to var47 in trigger 1, trigger 2 will be computed, and var47 will become free. Then again, independently from var0. You can surround this problem by affecting the value to some unused value, like -1 or any negative value, and add the state controller saying, if the variable stores this value, add in the opposite of this value. So that's more of a subtlety rather than a limitation, but you gotta think about it. Third, Mugen does compute the value to affect with its set of operators. You can move the var-set as var-add using var44 becomes var44 plus 1. You can use multiplications, exponentiations, and other math functions. You can put in if-else for even more concise blocks, etc. But remember that due to the second point, every time the variable is affected to 0 by these operations, the evaluation continues, an unwanted result may happen, so beware when you code. That makes up for a lot of theory, and the application of this glitch with immediate result may take time if you don't master these concepts in the first place. So here are some examples of applications. First, the Null-varset glitch may be used as a simple if-else loop. A block like this in Mugen will look like something like this in Python. So it overpasses the problem of two state controllers following each other up, where the result of the first will trigger the second, even unwittingly. Second, if your character has a move with different version, say Ryu's Hadouken, you may compile all in one single state using one variable as a version selector. Rice Pigeon does that a lot with its Toho RP characters, and it works great. Basically, if you have all your set of triggers ready, like in the traditional way, you can put them all in a trigger all using parentheses and double vertical slash, and put the common conditions in trigger 1, 2 with affectation to a version selector variable. I'm not especially fond of this technique, since it may be a loss of readability and comfort, but it can be useful for, say, state concisions. Third, and that one is very useful. If you want to give your character a characteristic that depends on the move he's doing, like an element, fire, thunder, ice, a talking animation, the velocity at which Venom moves his ball when he hits them, or even better, stun property and damage per rate. You can set up a state controller under the form of a table to assign set value to the variable depending on the state node, or additional conditions. It's clean, it's independent from trigger index order, you can read it really easily, and most of all, it rocks. That's it for the tutorial. Hopefully he helped and inspired you in applications to this glitch. There may be points that I didn't cover, so if you ever have a trouble, please ask me below in the comment section. Thanks for watching and have a good day.